Welcome everyone. In this video lecture, we will draw the two input NOR gate layout design which is based on the CMOS. Okay. So I have already draw the CMOS based two input NOR gate. Okay. A description about how to draw the CMOS based two input NOR gate. I have already made a video, so you can follow that video. So now in this video lecture, we will think about how to draw the two input NOR gate layout design. So first of all, before going to the layout design, I just want to show the different terminal which is present here. Like this one, I am saying this one is a source terminal. Okay, so before that I am just saying this one is our say M1 transistor, M1 M2 is the NMOS. Okay, this one I am saying M3 transistor and M4 transistor. Okay, so four transistor we have used, where this one is our source terminal. Arrow always signifies the source terminal. So this one is our source of 3. Why I am writing, it will be clear after 5 or 10 minutes. Okay, gate terminal, and this one is our drain terminal. Okay, and this one is our source of 4 terminal, arrow sign. Okay, gate of 4 terminal, and this one is our drain of 4. Okay, and this end is nothing but simply drain of M1, drain of drain terminal of M2 transistor, gate of M1. Okay, clear? And this one is our what? Source of S2. Okay, here also write source of S1, and this one is our gate terminal. Okay, that gate of 2 terminal. Okay, so before that, here two PMOS. Okay, here there are two PMOS and two NMOS are there. Okay, so first of all we have to make the PMOS. Okay, for the PMOS that we already know, we have to make some anvil structure. Okay, so I am making a, say this one, this one is our anvil structure. Okay, then after we have to draw the, what we can say, active area. So for the active area I am just taking the yellow one. Okay, or okay, first we are making for the clear this. Then after we have to make two polysilicon line, because there are two PMOS. So first I am just making these two structure. Okay, for PMOS. Okay, now this one is somehow okay. So now what we will think, see this one, this, okay, I am just, this haze line is red, is nothing but simply our polysilicon line. This one is our polysilicon line. Okay, and this one, the black one, is our what, n well. Okay, and this yellow one we can say the active area. Okay, I'm selecting different color, active area. Okay, and so one this one, the red one, is nothing but simply for the gate terminal. So for example, this one, this polysilicon is representing the gate terminal, sorry, just transistor M3. Okay, and this one was M4 transistor. Okay, M3 M4. Okay, so this one is nothing but simply gate gate of this three terminal, and it is connected to VA. So we can simply write this as a gate three terminal, and this we are giving input VA. Just I am showing how to just first make the transistor, and this one acts as a gate of four terminal having input VB. Okay, VA VB. Now we have to think there is a source terminal which is connected to VDD. So what I am saying, this in is our source of three terminal. Okay, this one is our source of three, and this should be our drain of third terminal, drain of third. Okay, now drain of third and S4. So this in is connected. So this one is our source, drain and source is here. Okay, and then gate is here. Then this will be our drain of 4. So this one is two transistor. Means in a stick diagram, for a brief I just want to show you. For the PMOS, okay, for the brief, for the PMOS, what we are doing, we have a yellow line. Okay, over that there is a P plus diffusion yellow line and red polysilicon. Then this in is our gate. So it should be either drain or source, or this side will be either source or drain. So that's very simple. But this is our layout, lambda based design rule. So we can write like this. Okay, that's why I have mentioned S3. So S3 is connected to VDD. So S3 is connected to VDD. So we will connect it later. Okay, so this one is clear. Transistor formation for M3, M4. Okay, at the end we will club it together. So this one is clear. Okay, we are not just putting the VDD and all it in, we will. So this one is the representation for the two PMOS. Okay, M3 transistor, M4 transistor. Now we are looking for the, suppose here also two NMOS is there. Okay, so for the two NMOS we are selecting the polysilicon. Okay, okay, we have to collect the rectangle. Okay, and I am for the, for the PMOS, oh, sorry, we diffuse P plus diffusion yellow color, and this one it will be the green color. Okay, so this one is the active area for the NMOS. Over that we have to again use some polysilicon line. Okay, here I am just, first I just want to show you how to make the transistors. Okay, then we will, okay, then after this one is our polysilicon line, so we can, okay, so this in is our what, M1. Okay, for I am saying this one is our M1 transistor. We are making for the M1 transistor. So polysilicon line you just basically for the gate one, but in between I am writing M1 and M2. So this int we can say gate of one terminal, and this should be gate of two terminal, the polysilicon line. Okay, and this one is nothing but simply VA input we are giving, VB input. At the end we will club all this diagram. Okay, so now here we can see this one is drain of there. See, the source S1 S2 is grounded. So for example S1 S2 I am making this as a S1 S2. Okay, S1 S2, S1 is there, gate is there, so it should be drain of 1, because this one is our NMOS. Okay, for the time being I am just, for the NMOS this one is a green line and red line. So if this one is our gate, it should be either source or drain or source. So I am just thinking this one is source one. So this middle one represents the gate and drain. Now this drain is connected to this drain. Okay, so D1. So this must be D1, D2 are connected. So these two, this will be also D2 for D2. Okay, drain of two term two. And this one will be what? Drain, gate, source. So this should be our S3. Okay. So now this one is our NMOS. Okay. So just I'm just making a for example demarcation line. So this one above this is our PMOS structure, okay, and below this NMOS structure, okay. NMOS PMOS is clear. Clear this one means how to make this two PMOS and two NMOS. Okay. Now once again, now we will try to club both the diagram. Okay, means it is very easy, but you have to slide careful. Okay. Now, for example, for I just do this again. Now we will make the complete diagram. Okay, means the so basically this one is the diagram. Okay, so okay, I can directly use this diagram also. So for example, okay, or I will make, okay, I will make the diagram in new way. Okay, once again. So first of all, I'm just making the what we can say PMOS. So two PMOS. So we have to select this one, okay, for the anvil region. Inside that, for active area, we can say one yellow line I am taking, okay, yellow block we can say, yellow rectangle, okay. Then after I am doing one more rectangle, okay, for the PMOS. Sorry, PMOS is done. Now for the NMOS, one green line, okay, one green line we have already made, okay. Then after what we can do, simple, we have to both the this gate VA, this gate having the same input G3 and this one G1, okay. So there will be, because these two gate is connected, G4 and G2 is also having the same value, so two polysilicon line we have to make. So for this purpose, okay, I am making two polysilicon line because we have to make four transistor. So this one is our polysilicon line, okay, clear. You can also make this as a hash line, okay, or just leave it for the time being. Okay, now see this one, what I told earlier, this one is our what, source of 3, okay. So first select this one is our S3, okay, and this one is our M3 transistor having this in its gate of G3, gate of G3 we can say, and G3 and what, G1 having the same value, G3 and G1, okay, having the same value, that is our VA. So I am just representing like this. So S3 and this one is gate 1, so this should be our drain of 3, okay. Now drain of 3 is connected to S4, so this should be our also our S4 terminal, and this one is the gate terminal, that is our G4, okay. So this polycyclical line is G4 and having the same input as G2, so you can write G2 and we are giving input VB, okay. S3 gate, okay, and this one is what we can say M4 transistor, okay, you write it, and this one is our M1 transistor. For the M1 M2, just for the notation gate, okay, this one is source, so this should be our drain of 4 terminal, drain of 4. Similarly, if I am writing this as a S1 gate, it should be our drain of D1 and D1 D2 connected. Then after this should be our what, D1 D2 is connected. Now this will be drain gate and this will be source S2. So now we have made the terminals. Okay, now what we have to do, here we can see we have to give the supply VDD to the source of S3. So what we have to do? Okay, for the this time I am just taking some space for the, and for this thing what we can do. Okay, I am taking black. Okay, here for VDD, or I'm just to make it more, means in this diagram we are sometimes just violating the means the distances, means the what should be the length, there should be the separation. Okay, but this is the rough diagram I am saying. Okay, so first, okay, so this one is for all VDD line. Okay, or directly you can also make, or you can directly in book they are making like this. So okay, so this will be our VDD, for VDD line. Okay, VDD. Okay, clear. And we have to make a contact. Okay, so make it with a black color with this active area. Okay, so this one will be the contact. So now VDD is done. Okay, now D3 and this S4 is connected. Okay, so no need to disturb. Then we are taking output from the D4 in. Okay, D4 in, and in between D1 and D2. Okay, we have to make the output in between D4 and D1 and D2. So D4 is there. Okay, so what we have to do, take a, okay, D4 from this D4, and in between, okay, wait, okay, why, then we have to erase this side. Okay, means see, this drain of 4 and drain of 1 and 2 is connected. Okay, so what we can do here, we have to make it contact. Okay, okay, and here also we have to make a contact, and this one is our what we output. Okay, so we can simply write this as a V output, which is D4 and D1 and D2. So D1 and D2. Okay, our this part is over. Now the source of 1 and 2 is grounded. Okay, source of 1 and 2 are grounded. So we have to connect source and 1 and 2. So again I am just taking some rectangle area. Okay, not pink. Try to take black color. This, okay, and then, okay, and then we have to make it contact. Okay, so for this contact, make it black. Okay, or you can extend this one, or this is nothing but simply your ground connection. Ground connection, S1 and S2, the source of S1 and S2 is connected together. So this one is our ground connection, output connection, and we are giving input as a VABB. So this is our the layout diagram of a CMOS two input NOR gate. Okay, So this is all about the, or in some book or in some paper, you can make it hairline to make it more attractive like this. Okay, clear this thing. So clear. So first we have to make this one PMOS and NMOS. Then we have just combined all these thing and we have made this diagram, and this one is our CMOS, two input NAND gate. To for more detail you can also follow the CAG book. Okay, so this is all about the two input NOR gate layout design based on CMOS. So this is all about this lecture. So thank you for watching this video. Thank you.